We are talking about transformations of quadratic functions, and we want to graph quadratic functions in intercept form and write the equation of a quadratic function in intercept form given the x-intercept and a point. So here we have the function h of x is equal to negative x times x minus 4, and we want to compare it to the parent function. Calculate the given information. So first of all, we want to calculate the x-intercepts, and that is going to be by the zero product property. And what that means, if you multiply two things together, if one of them equals 0, then they both equal 0. So what we're going to do is set them equal to 0. So the first one we have is negative x. So we're going to say negative x equals 0, divide by negative 1, divide by negative 1, and we get x is equal to 0. Next one that we're going to look at is the binomial x minus 4. To set that equal to 0. So x minus 4 equals 0. Add 4, and we get x is equal to 4. So these are the x-intercepts. So we have one at x equals 4. So that's going to be 4 comma 0. And then we have another one at 0, 0. Next, we can calculate the axis of symmetry or the line of symmetry. So that's the axis of symmetry. And we want to use our equation. And the equation that we know for that when we're given our intercepts, the equation is x equals, we know that we're calculating the average, so we want to make sure we use addition. And we know that there's 2 points, so we're going to divide by 2. So then we're going to add the p plus the q and divide by 2. So we substitute those values in, and we get those from over here. The addition sign is going to stay, division sign is going to stay. The p value is 0, and the q value is 4. So then we get 0 plus 4 is 4 divided by 2, which is equal to 2. So our axis of symmetry is x equals 2. And then we can graph that on our grid. So we got x equals 2. So now we have our two intercepts and our axis of symmetry. Next, we want to think, is it a minimum or maximum value? And we want to pay attention to what the a value is. So in this case, a is equal to negative 1 because we have the negative out front. So we know that our graph is going to open down. And if the graph opens down, that means that our vertex is going to be a max. So our vertex is going to be on the top, which is going to be a max value. So in order to find out exactly what the max is, we need to take our axis of symmetry and substitute it into the equation. So our equation is h of x equals negative x times x minus 4 And then we can substitute in 2 for all the x's. So we get the function h evaluated at 2 is equal to -2, and then 2 minus 2, or 2 minus 4 is -2. So the function h evaluated at 2 is equal to 4. So our vertex, we calculated our y there, and we calculated our x over there. And so our vertex is 2, 4. So that's where we got our x portion from our axis of symmetry, substituted in and calculated our y, and that gave us our vertex. So our vertex is located at 2, 4, so over 2, up 4. And we want to think about what does the rest of the graph look like? And we want to compare it to the parent function. So the parent function tells us that when we go over 1, we go to the right one. As you can see, if we go to the right one, then we go up 1. And then if we go to the right 2, then we go up 4. And if we go to the right 3, then we go up 9. So basically we just square that, right? So 0, 0, then we go over 1, up 1, over 2, up 4, and that continues through. Now in this case, our a value is -1. So we take our y portion of that, and then we multiply it by -1. So instead of going up 1 from the vertex, this is from the vertex, instead of going up 1, we go down 1. So we still go over 1, now we're going down 1. From the vertex, we multiply that by negative, and that becomes down 4, and that becomes down 9. So from the vertex, we go over 1, down 1. So over 1, down 1. Over 2, down 4. Over 2, down 4. And that is our intercept, which we already had graphed. And then we go over 3, down 9. 1, 2, 3, down 9. 1, 2, 3, 4, 6, 7, 8, 9. So that's our right side graph. Now we can count, use our axis of symmetry and the points that we know, and we can reflect it to find the other points. So over 1, over 1. Over 2, back 2. That's our other x-intercept. Over 3, over 3. And now we have a pretty good amount of points in order to sketch our parabola. So the last thing that we need to think about is our domain and range. And these arrows down here tell us certain things. So for the x direction, although this arrow mostly looks like it's pointing down, there is still a horizontal component to it. So this horizontal component means that it goes to -infinity, and this one means that it goes to +infinity. So the x values for this parabola go from -infinity to +infinity. The range is the y values, and the y component for those arrows means that it goes to -infinity. Both go to -infinity. So we always start with the lowest value, and obviously -infinity is the lowest value. And then we see where it goes to, and we're looking for the y value. So the highest point, or the maximum, is at 4. and 4 is included, so we use a bracket. Whenever we have infinity and we're talking about domain, range, or increasing or decreasing, we always use parentheses. Next thing that we can talk about is increasing, because as we start here, we can see that our graph is increasing. It's going up from left to right. As we read it left to right, we can see that our graph is increasing. So we start increasing at negative infinity all the way until we get to 2. Now 2 is not included because the slope at 2 is actually 0. It's neither increasing nor decreasing. Once we get to the vertex, it goes from increasing. Now we're back to decreasing. Now we're decreasing. And we start at 2, not included, and we go all the way to positive infinity. Increasing and decreasing, we're looking at the x interval. So although we're reporting the x interval, reporting the x interval based on what the y is doing. Is the y increasing or decreasing? But what we write in the interval are x values.